Alright, so now suppose that we have got a linear equation, but it's not in the nice slope-intercept form that we're used to seeing. So what if we have like 5y equals 10x plus 15? Well, what do we do? So we can, to get into y equals mx plus b form, we just gotta solve for y. So here it's pretty easy. We just have to divide everything by 5. So we've got y equals 2x plus 3. And then we can just graph that as usual. Y-intercept is 3. Go over 1, up 2, because that's the slope. And there's our line. How about something a little bit trickier? What if we have like 2x plus 3y equals 6. So here we have to solve for y. So let's first get y alone. Let's move that 2x to the other side. So minus 2x from both sides. Then these x's cancel out, because that's like 0x. And then we've got 3y equals 6 minus 2x. Now we're in kind of the same situation as before. So all we got to do is divide by 3. And we get y equals 2 minus 2 thirds x. We can rewrite that as y equals negative 2 thirds x plus 2. So that's in y equals mx plus b form. And then we can get on with graphing it. So go up 2. Let's say this is 2 right here. And tells us to go over 3, down 2, according to the slope. So if we go, well, when we go down 2, we're just going to be hitting the x-axis, because we're starting at 2. So we go down 2, and we're going over 3. 1, 2, 3. Something like that. Okay, let's do one more. We'll make this a really tricky one. Why don't we do something totally ridiculous, like 5 times 1 plus x plus y minus y equals x plus 2y divided by 3. Okay, that looks really ugly. That looks like a really ugly equation because it's got a bunch of multiplication, a bunch of fraction stuff going on. But that's going to simplify to a really nice linear equation. So let's go pretty it up. So first thing to do is, I always like to get rid of fractions first, just because it's easy to do arithmetic mistakes with fractions. I still do it all the time, and I've been working with fractions forever. So let's just get rid of the fraction. Let's multiply both sides by 3 times 3. That's a times, not an x, just to be clear. And remember, like, whenever you times or divide things, you gotta times or divide every single term. So times 3, this side goes to x plus 2y. This side goes to, well, you can think about timesing this 5 times 3. So it's like 15. 1 plus x plus y. Maybe we should have distributed it first just to be clear, but yeah, you can figure it out. Then minus y times 3, that's minus 3y. Okay, now if we distribute this over, we get 15 plus 15x plus 15y minus 3y equals x plus 2y. And then we can group like terms, like this 15y minus 3y, that's 12y. So 15 plus 15x plus 12y equals x plus 2y. And then let's minus x and minus 2y. Minus x minus 2y. And we get down to 15 plus 14x plus 10y equals 0. So now when we solve for y, so we're going to go back up here. Try to write smaller so we have enough room. So let's subtract the 15 and the 14x to the other side. So we get 10y equals negative 15 minus 14x. And then y equals, we'll just divide by 10. Negative 1.5 minus 1.4x. We could have worked with fractions, but I guess since it's only one number past the decimal place, it's not too bad to work with the decimals here. So let's graph this. So maybe we should write y equals negative 1.4 x minus 1.5, just because that's what you're used to seeing the y equals mx plus b. So our intercept here, our y-intercept is negative 1.5. So if this is 1 and this is 2, we're right in the middle of that. And then we go, our slope is negative 1.4. So every time we go over 1, we got to go down 1.4. So if we're at negative 1.5 to start with, and we go down 1.4, we're going to be at negative 2.9, which is right under that 3. So it's somewhere about here. And that is our... I missed it again. Let's try it. Maybe I should just start at this point then. Yeah, that works a little bit better. Okay, that's our line. Yeah, so this whole equation right here was really just a line in disguise. It had an ugly mask, and once you like give it some affection, give it some love, then it pretties up and becomes this beautiful thing.